Hello everyone, I am DEVANSHU HARISH BORKAR, third year engineering physics student at IOT Roorkee. Today I am going to present on the topic weather monitoring system using IoT for my course Applied Instrumentation. So moving forward to the next slide. Introduction to weather monitoring system using IoT. So first of all, what is a weather monitoring system? It is a device that collects data related to the weather and environment using many different sensors. It is also a facility that can use for measuring atmospheric conditions to provide information for weather forecast and to study the weather and climate. A modern weather monitoring system using IoT technology, IoT means Internet of Things, technology enables a real-time data collection and analysis for accurate forecasting and decision making. The system integrates sensors, data transmission, and a cloud computing to provide comprehensive weather insights for various applications. Now coming to the problem statement, the problems we are facing in the lack of a proper weather station or a weather monitoring system. As we know, weather conditions have an impact on human activity and monitoring the weather may aid in regulating it. It is crucial to observe and research the local weather patterns. The users has very few options for learning weather information such as temperature, humidity and wind speed. Without a weather station, a user cannot get notification of heat waves, severe winds or other weather related emergencies. And as we know, it is so much challenging to make weather forecast without the historical data. When using a weather station, a user may also access historical data. The user can identify measurement trends. It will make it possible for users to examine trends more successfully. Now coming to the objective. Our main objective is to create a real-time weather station that enables users to obtain data instantly and anywhere using Internet of Things. We want to develop weather station that can help users to plan their day-to-day activities. Now moving to the next slide. Now, importance of real-time weather data. As we all know, early morning systems are totally based on real-time weather data. Real-time weather data allows for the early detection of extreme weather events and extreme conditions. Now, impact on agriculture. As we know, weather has a drastic impact on crops. As we know, the crops can get highly damaged due to bad weather conditions. So farmers can make timely decision based on accurate weather forecast. Now, public safety. Real-time weather updates enable authorities to issue timely warning and ensure public safety. And as we know, weather systems are so much important to be prepared for a disaster. Disaster preparedness helps in better preparedness and response planning for natural disaster and emergencies. Components of the IoT weather monitoring system. First of all, sensors. It is made up of different sensors to collect data of temperature, humidity, wind speed, and precipitation, etc. Second, gateway. A gateway is to collect and transmit data from sensors to the central server and cloud platform in real time. Third one is dashboard. It offers a user-friendly dashboard for monitoring and managing the collected weather data and system. The last one is power supply. As we know, it relies on a reliable power supply to ensure uninterrupted operation for the monitoring devices and components. Sensors that are used for collecting weather data are first node MCU, second DHT11 sensor, third rain sensor, fourth one is LDR sensor, and fifth one is LCD display. Now coming to our first sensor, that is node MCU. It is an open source single board microcontroller based IoT platform that is inexpensive. It has a storage capacity of 4 MB and 128 KB of memory. A dual inline package DIP is a circuit board that combines a USB controller with a small surface mounted board that houses the MCU and antenna. It originally came with firmware that works on the ESP8266 Wi-Fi SOC system. Access to GPIO, that is general purpose input output, is also provided. The second one is DHT11 sensor. It is a crucial, extremely low effort computerized temperature and humidity sensor. It measures the air around it using a thermistor and a capacitive humidity sensor, and it outputs digital data on the data pin. It has an 8-bit high performance microprocessor built in, and it is of outstanding quality, responds quickly, and it guarantees long term stability. The specifications are operating voltage is 3.5 volt to 5.5 volt. The operating current is 0.3 milliamperes. The temperature range is 0 to 50 degrees Celsius and the humidity range is 20% to 90%. Now, the third sensor is rain sensor. A simple instrument for detecting rain is the rain sensor module. When a raindrop passes through the rainy board, it may be utilized as a switch and it can also be used as a gauge. The analog output is utilized to monitor decreases in rainfall volume. The LD will turn on when the induced board has no raindrops, and the DO output is high when connected to a 5-volt power supply. When the DO output is low and a little amount of water is dropped, the switch indicator will turn on. On removing the water droplets and the output is high when it is returned to its original state. A switching device that is triggered by rainfall is known as a rain sensor or a rain switch. Now the fourth one is LDR sensor. Essentially, it is a variable resistor where the resistance changes as the light intensity increases. More light means less resistance. Light intensity and resistivity are inversely related. The LDR sensors is used to distinguish between day and night. The specifications are their sensitivity is very high. They are simple and small devices, easily used, and it is inexpensive. Now, 16:2 LCD display. A liquid crystal display, sometimes known as a LCD, is essentially a display device made with liquid crystal technology. When creating projects based on real-world electronics, we require a way to show output values and messages. That is the main work of LCD. We collected our data from sensors. Now it is the time for data transmission and storage. The methods we use for data transmission is wireless or cellular. The data is stored in cloud storage or local servers. And during this, the security measures is encryption and access control. Now the next slide. Now, data visualization and analysis, as it plays a crucial role in understanding and interpreting the gathered weather data. By visualizing the data, trends, pattern, we can identify anomalies and informed in decision making for various applications. Integration with weather forecasting models that are mostly ML based models. It has three steps: data gathering, model calibration, and prediction enhancement. Real time weather data collects feed into forecasting model calibration, calibrate forecasting algorithms with live sensor data for accuracy, and using historical and real time data, we can improve our prediction. Now, coming to the benefits of using IoT for weather monitoring. Utilizing IoT for weather monitoring enables real time data collection and analysis. The seamless integration of IoT device allows for accurate and comprehensive weather observation. By leveraging IoT, weather monitoring system can provide early warnings for natural disaster and optimize resource management. Challenges and consideration. First of all, data accuracy. We need precise and calibrated sensors for accurate data. Second, power consumption. We have to use energy efficiently for its long term deployment. Third is network connectivity. As the data transmission is completely rely on network connectivity, so we need a good network connectivity. The last one is environmental conditions, as we have to protect the equipment in harsh weather conditions. For that, environmental conditions should be considered. Now, future development and enhancement. We can enhance it by using small sensor, more accurate sensor for precise data collection. We can utilize machine learning for more accurate weather predictions. The efficient transmission method for fastest real-time data updates. We can integrate with AI using AI algorithms for more intelligent weather data analysis. These are some ways to enhance the weather monitoring system for the future. That's all for my presentation. Thank you.